Hello, everyone. I just wanted to go over a few things that we are expected to know. The first one, as you remember, everyone out there in Zoomlandia who pays attention, basically we're doing the D binom because we went over everything with the binomial. So what I want you to know is essentially, oops, wrong one. The D binom function is very important for asking essential questions about the probability. So if you're wondering, as I said, I'll just use the same examples I use in class. You're a landscaper. You just want to know what's the likelihood that 5 trees that are not indigenous to Arizona will survive Arizona heat out of 20 when there's a 25% chance of survival. So that's what we call the D binom function. And it's a very important function. So there you get, about a 20% chance. Remember, it's just success or failure. There's only one with the binom. It's like an experiment. We're only dealing with the 5. So if you ask, what about 6? Well, it seems like there's a lesser chance of 6. But then if you ask 1, as was asked about, it's even going to be lesser because, see, just about 2%, because there's a stronger likelihood of probability that 5 is about the best you're going to get with those numbers. So you're essentially asking these binomial questions. And if you want to know what is the likelihood of each one from 1 to 5, you just use the doble punto there in Spanish. And you see, for 1, it's about 2%. For 2, it's about 6%. Then you go up. Okay, so the likelihood is stronger at 3, then 4, then 5. But then what about if I change this to 6? Then you get, there's a likelihood it starts going down. So your best likelihood there with those numbers, now these are kind of arbitrary numbers, but they're still useful, is 20%. Now that's important for everything. In statistics who are using, that is like businesses, etc. Because if you're working at Amazon or any kind of, that's right, I don't want to give that bozo guy any, free commercial. But anyways, any business that you have, you want to know what's the likelihood of defective products. So if you say, for example, want to know what's the likelihood of getting 4 products that are defective out of, say, 20, and there's a 10% chance, that you can basically do that. Excuse me. So if there's so the D binom function here, if you want to know what's the likelihood when it's 10%, what's the likelihood of 4 out of 20 when there's a 10% likelihood that there's a defective product, you get, that's pretty low. That's just an 8% chance that you'll have 4 out of 20 when there's a 10% likelihood that, or probability that there is a defect. So these are arbitrary numbers. And again, remember the P binom, I put them up here so we can run through it. That gives you the cumulative, so it's very high because it's not asking you now just the 5. It's asking you 1, 2, 3, 4, or 5. So that's P, probability binom, is the probability you'll get up to 5. 1, 2, 3, 4, 5. If you use the survival of trees, if you plant 20 trees, you want to know what's the likelihood at least 5 would survive, either 1, 2, 3, 4, or 5, or up to 5, sorry. And there's a 25% chance of survival. You get a pretty good chance, but that, could be only 1, 2, 3, 4, or 5. And again, the binomial test, very important in in this because we went over it as the first test. So you basically have a binomial, but you want to test. So the good example I used was, I was told by experts that Bernie Sanders would win 75% of the Iowa caucuses, or caucus, I don't know what you say. So anyways, so he won 39 out of 50. Is this 75%? And this is an important question when we essentially do that. Oops. Sorry about that, mate. And then that we get it. Sorry, I just had to change the B. It was a capital B. Remember, it's very case sensitive. So here we have the number of successes, 39 out of trials, 50. The p-value is 0.7. Now, this is going to be incredibly important, because this is where we introduce the p-value. Now, it's a little different here because when we get to the null hypothesis, etc., but the point is that when it's under, and I'm going to explain this, I have explained it, we're going to explain it more, we're going to have more videos on this, etc. What is a significant p-value? Now, again, I can't highlight enough the fact that the p-value might be a little overused in statistics. We're going to have other coefficients. And when we get to that, the regression with the ice cream, survival, just a broad range of data sets, multinomial, etc. We're going to see different coefficients. But for right now, for the p-value, we only reject this hypothesis here, which when we get into it, it's going to be the null hypothesis, but this is different. But what we have here, that 39 out of 50 is roughly 75%, which means we do not reject it because it is not below 0.05, which is the alpha, which is the level of significance we put for the threshold for the social sciences. Others, 0.1, especially in businesses, defective products and stuff like that. But for right now, 0.05, that's significantly higher. So we accept this hypothesis, and we do not, as this says, accept the alternative hypothesis, which would be the true probability of success is not equal. So is it equal or isn't it? It's like success or failure. Again, with the binomial, just win, lose. You basically have only one thing. I compare this to like sports teams or anything else. The Patriots will or will not win. And they did win, surprisingly, without Tom Brady. But that's a different story. So we accept this and we reject the alternative hypothesis that the true probability of success is not equal to 75%, not equal. So it is equal. But what happens if we change it? Then we say something like, remember, you can hit the arrow, it goes right up. Let's say 10. Okay, we get a p-value. Again, I told you with the 10th, the e, that's under 0. So now that the p-value is so small, under 0.05, we reject the idea that 10 out of 50 is 75% and accept the alternative hypothesis that the true probability of success in this binomial test is not equal to 75%. Now, a lot of people might say, as I mentioned in my classes, oh, well, that's obvious. I could have just looked at it and told you. That's true. But when you're running a large amount of statistics, when they get closer, you don't want to rely on just, an innocent eye to tell you. You want to run these tests to make sure. And these are very important because, let's say, for example, if, you're expecting if 75% of products are defective and you get 10 that are defective out of 50, that's not even 75%. I mean, that's obviously a really high number. I highly doubt there's any business that could have 75% defective products, but regardless, it still stands. It goes, oh, that's pretty good. That's not even close to 75%. So we did well. We don't have as many defective products. Maybe that's the Tulsa or something like that. It's like 75% of the cars blow up. And, you know, this is actually a good batch because only 10 out of 50 went on fire. I'm just kidding. I don't really know much about the Tesla. But anyway, the point is that that's your binomial test. I wanted to just wrap up with something you people need to know, particularly for quizzes, tests, etc., is the combine function here is that if I give you numbers, you're going to have to put that in with the C. And so it's, what is it, concatenated or something? That's the bigger word for combined. It makes me feel smart, but I really can't say it correctly. So this is the combined function. So if I give you these numbers in a quiz, a test or something, and it's 100, let's say this is income, 100,000, 150,000. These people are rich. 103,000, 69,000. There's me, $42,000 dollars. I'm kidding. I like make it a little more like that, but you know, 1980 salary. Nice. And I want to correlate that with LSAT scores because there's evidence that income correlates with the LSAT, GMAT, etc., GRE, the SAT, etc. LSAT is for law. You want to do it, but you want to make sure they're there. So all you do is put it in. It should pop up like that, so you know it's there. Oh yeah, income. There it is, and then the LSAT. So there, you have to use that C combine function in order to create anything. And you can call this anything, right? I mean, you can call it Q. You know, you can call it your name. You can do it. I'm just saying this is income and LSAT. So again, with the correlation, this is kind of neat because a lot of places would want this kind of data. You want to know what is income and LSAT. Oh, wow, that's I did that on purpose. That's like an almost perfect correlation. And I did it purposely, but you know, that's probably not what it's like in the real world. The goal there was saying you have to use the combine function in order to make these graphs. So we were doing the Excel sheet before, the CSV file, we put it up and then, you know, we attach it. This is a different way. So if I ask you these numbers, and I'll give you them in the row for a quiz or a test, you have to essentially know them like that. But that's almost a perfect, now we have to graph this because that's crazy stings. I wasn't going to plot it, but since I made it so things. Oh, wow, look at that, straight up. And as people remember, the ab line, we might as well do that since we're here. Income, and then ab line. All right, look at that line. Wow. So that is the line of best fit we were reading about. Wow, look at that. There's only 5. So 1, 2, 3, 4, 5. That is an awesome correlation. The real world rarely looks like that because look at that perfect fitting line and look at the small, you know, sums of squares must be, I mean, really low residuals. We could really run it like we did the other day. So let me take a look. Yes, look at that P value. Look at the very high T value. Oops, sorry, T value. Oh, wow, it's not that high. It's only 2 stars. See, this is where we get about what is the P value, but look at the multiple R squared. So that's so interesting because when we ran the ice cream, it was, in temperature, the P value was more significant, if you will, lower than 0.003, sorry, 0.003. But yet the multiple R squared wasn't so high. See, this is why you need different coefficients and different measurements to see whether something is correlated or not. And I'm glad we did this test like this because, here it's saying income, oh, wow, it's significant, but not super significant as some people say. I mean, we overplay the p-value, but many would argue that if it was lower than 0.003, it's only got 2 stars opposed to 3. And you see, this is the estimate. Don't forget that with every unit of X, that is income. And that's a really big high thing. You get a 0.40 score, or 0.39 score higher with every unit of income. And the standard of error is pretty low from my point of view. Again, these are all, what is low and high. But if you notice, the residual standard error is pretty low at just 3.75, which is basically, how well our model is doing. This is the deviation of the general model away, what it's not explaining. This is how much it does explain, which is very high. And this is the extent to which it deviates. These points deviate from the line. And as you can see, it's very small. So that's good. It's not supposed to be good. You're not supposed to want something. You're supposed to let the data fall as they may. But as you know, you do want your model to kind of work. But then there comes biases, etc. Because if someone takes, say, for example, creates a vaccine, they want it to work, but that's a little unethical because then you start, changing the numbers around. But this is an excellent example. This will be a good question on the quiz. For why the p-value is valuable. It's only 2 opposed to 3, like in the the temperature consumption of ice cream example. But yet the multiple R² is significantly better, the coefficient of determination. And then the residual error is low, which is good. There's less residuals that's deviating from these means from the line. And then the income with every more unit of the X, which is income, there's a increase in the LSAT score of 0.39. I'll just say 0.40. And the standard of error, that is if we repeat the study over and over again with different, say, cases, a different sampling, then this is the range. This is just an estimate, remember. It's tough to do, I think. But regardless, these are very good numbers. Why isn't the p-value even lower? And that's what's kind of interesting. You have to start looking at these the F statistic, the p-value, again, the same, because the F statistic, remember, that is really pertinent when we have more independent variables, the same with adjusted R², which is going to be always lower than the multiple R², which is the normal R², and the adjusted is if we start putting on more independent variables. It's kind of like a punishment to that. So I hope you kind of got the gist of this. We did a lot in Zoom, and I want to continue with this structure. This is very good to be this advanced, I think, in statistics in just the first week or two. So you should be happy if you're up to this level already, reading everything from the estimate, reading the p-value, the t-test, the residual standard error, the RSE, and that's named something, a few other names in other places we'll get to later, but R calls it residual standard error. There's some differences people say, but by and large, it's the same in Stata as PSS and other packages, but they call it different name. Multiple R² is just R². I don't know why they name things certain things, but that's very interesting. So, if you have any questions, comments, give me an email, or better yet, leave something in community forum. I hope everyone's staying safe out there in the middle of COVID. Great seeing you, and take care, everyone.